spearheaded a lot of our fundraising efforts. The scholarship that is made every year goes to a student pursuing their master's in the Fish, Wildlife, and Conservation Biology Department at CSU. This year our student is Nitsa Platis. She's originally from Washington State, where she grew up and surrounded by nature. Today she is sharing some of her current research, which is focused on the ecological impacts of dams on the community. So, here's Nitsa.
Got it. Just take a moment.
Okay.
We just got it.
She got stuck in traffic. So. We're glad she made it.
All right, thank you everyone for having me out here today. I really appreciate it. It's an honor. Okay, thank you. I usually don't have the microphones. We have small enough classrooms that we don't have microphones. We sometimes have those, but oh, yeah, we get real.
Make sure the caption's at the corner of her mouth.
Can you guys hear me?
There you go.
Okay.
Awesome.
Is that too loud now? Okay. Cool. Yes. Thank you. Okay. Well, thank you all for bearing with me through this technical difficulties. So like it was mentioned, I'm a CSTU grad student. I'm studying fish, wildlife, and conservation biology out there. And today I'm presenting on some of the research that I've been working on while I've been at CSU. And specifically, we're looking at trophic niche dynamics of brown trout and model sculpin in a regulated Rocky Mountain River, the Blue River, which many of you may be familiar with. So before we begin, I'm sure a lot of you think mottled sculpin and you think they might be a prey item for trout, but they actually share a lot of similar resources with trout. And as we'll learn from today's presentation, they may actually be potential competitors, competitors of brown trout. So to give you guys a little introduction and background, food webs represent the network of energy between, sorry, can I move these little screens?
Yes.
Cool, thank you. Sorry. So food webs depict the complex network of feeding relationships within an ecosystem. And within a food web, there are different trophic levels. So higher organisms in the food web represent higher trophic levels. And then on the other hand, a trophic niche represents all the resources an organism utilizes for energy. So as we can see in this example, a tuna's trophic niche consists of herring, squid, and anchovy. It's really important to note that trophic niches are really dynamic and they change with shifts in resource availability in their environment. And the concept of trophic niches are especially important when we're studying the impacts of dams, because dams actually influence what resources are available in the river. So it's very relevant in understanding how dams are impacting food web dynamics. So dams can significantly alter the environmental conditions in a river through several primary mechanisms. For one, they modify the flow regime. We either divert water to other users, which limits the amount of water that is available for downstream rivers. And then we also store water and release it at different times for agriculture or for hydroelectricity or various other reasons. So this changes the flow regime, the natural flow regime of a river, which can have a lot of implications for the ecosystem because the natural flow regime of a river regulates the biological, chemical, and physical processes. So another example of how dams alter ecosystems is that the water in large reservoirs becomes thermally stratified. So as you can see in this diagram, the water is divided into two different layers. The top layer is a little bit warmer in temperature and it doesn't mix with the bottom layer of water, which is a lot colder in temperature. And because of this, when dams use hypolimnetic water releases, which means that they're releasing water from the base of the reservoir, that water is a lot colder in relation to natural rivers during the summer. And then there's also a lot less variability that you would typically see daily and as well as seasonally. And this is important because temperature cues a lot of species-specific life history traits, such as fish spawning and eggs hatching, as well as macroinvertebrates emerging from the water. And then lastly, as we can see in this diagram, a lot of sediment and debris are trapped behind the dam. And so what's being released outside of the dam is actually limited in nutrients and in sediment. And sediment plays an important part in making sure we have the correct habitat or habitat heterogeneity downstream of the dam. And so this can have important implications for habitat homogenization, which is not good for fish or macroinvertebrates. And then nutrients, of course, serve as the base of the food web. So a lack of nutrients means that there will be depleted algae productivity, which is important for macroinvertebrates and then the rest of the food web. So as I kind of just explained, a quick example, if we have a dam and it's limiting nutrients, this is going to reduce primary production, so algae productivity in the river, and in turn, this is going to affect a lot of primary consumers, such as caddisflies and mayflies. And because this limits the primary consumers in the river, this is now going to limit the resource availability for fish in that system. Another example is that dams actually change the rate of change of flow in a river. So we'll see these sudden jumps in flow magnitude or sudden drops in flow. And this can be important for sensitive taxa, such as mayflies or trout eggs or trout fry. If we have a sudden increase in flow, that's going to flush them downstream and can kill them. And if we have a sudden drop in flow, that will actually dry them up and they'll die because they won't be in the middle of the stream. So these impacts have far-reaching consequences for the ecosystem, and they kind of outline the importance of understanding how dams are impacting different regimes within the river and understanding how that's going to scale up to impacting the food web and biota in the ecosystem. So let me take a quick water break. And feel free throughout this presentation to tell me to slow down, or if you guys have questions or want to jump in with comments, it's very casual. I don't need to have an ongoing script. But our study system is the Blue River, which is located in north central Colorado. I'm sure some of you have fished there before or visited that area. It's really beautiful. It's a tributary of the Colorado River, and it has two dams along it. And since those dams were constructed, they've really changed the ecosystem downstream of those dams. And some primary concerns are that one, it's a nutrient sink. As we saw in the previous slides, dams will trap the sediment and nutrients. So it's oligotrophic or nutrient depleted downstream of the dam. And then also this dam, Green Mountain Dam, releases water mainly from the base of the reservoir. So that means it's going to be changing the thermal regime of the river. And then third, especially the lower portion of the river, the lower Blue River, has highly altered flow regime because of the demands that it's trying to meet with agriculture and hydroelectricity. Yeah.
A lot of these dams are always complaining about the sediment load that's building up in them and how that's keeping their capacity. Has anyone looked at stirring the sediment up and
Yeah,
getting rid of some of that nutrients.
right, yeah. Oh, yes, he asked if anyone has looked at stirring up the sediment that's at the base of reservoirs because they are sinks and if that will help. I honestly don't know if that's something, especially if that's been done in Green Mountain Reservoir before. I haven't heard of that, but that could be a possibility. The other thing is that's fine sediment that's being released downstream, but there's also the implications of all the other sediment that has been trapped. So you're not going to get the suspended, like, right. Yes. So a lot of issues, and it's pretty complex. I don't know all the nuances behind it. Yes, exactly. Maybe in a few years I'll be able to answer that question. But yes, the third, like I said, the third big issue is the highly altered flow regime, and it's really impacted, as we'll see in the coming slides. So this hydrograph is showing the variations in annual flow in the lower Blue River pre and post dam. So Green Mountain Dam is built in 1943. And as you can see, the flows on the left of the dotted line look a bit different. First, there's higher magnitude. So we're seeing that the flows used to be reaching 3,000 CFS, whereas now the magnitude is a lot lower. And then we also see a lot more static within those hydrographs on the right, which means that there's a lot more intra-annual variation in those flows. And although this hydrograph is helpful for visualizing overall trends and changes in flows, it's helpful to take a closer look at an individual year to understand how the dams are impacting flow patterns within a year, because that's what's really affecting the ecosystem. So moving on to the next slide, here we're comparing pre-dam flows in the Blue River to flows in the Eagle River, which is a nearby river, and it's considered natural and unregulated. And so as we can see with these two hydrographs, these two rivers have very similar flow patterns prior to the dam being constructed. And this is really important because it allows for us to take a look at current day flows in the Eagle River compared to the Blue River, and be able to understand how those flows should be looking in the Blue River if the dam wasn't impacting those flows.
Let me ask you a question. So Blue River, Blue Line, and Eagle, they almost look identical.
Yep, yeah.
And Eagle, you said, is unregulated. So are they trying to mimic the Blue prior to
Yes,
the dam?
sorry, I'm talking very fast.
Oh, okay, no, that's good. Now I understand.
Yes, the next slide will be showing current conditions of the Blue River compared to the Eagle River. Any more questions or comments on this slide before?
So this is before.
This is before the dam. So this is just showing you guys how similar the Blue and Eagle are. And now if we look into the future, hopefully the Blue River would look like this, or look like the Eagle River flows. But as we'll see, they're very different, which is showing that the dam's really impacting the flow regime. Any other questions? Yeah. Yeah, so the Eagle River is right next door, so it shares a watershed boundary. And then it has a similar drainage area, similar elevation, a lot of similar qualities. And the next part of my project is actually being able to compare a few other things like nutrients, temperature, and macroinvertebrate communities. So it's a really unique situation. Honestly, there's not a lot of rivers in the country where you can compare an unregulated reference stream that hasn't been heavily impacted to a regulated stream. And when you make these comparisons for flows between the rivers, usually they area normalize the flows to account for differences in watershed areas. But we just plotted this raw data and they looked so similar and have very similar watershed drainage areas that we were able to not even modify the data and just do raw data back to back, Blue versus Eagle. Yeah, of course. Okay, on to the next slide. So this hydrograph is comparing flows now in 2021 from the Blue River and the Eagle River, which was the reference stream in the previous slide. As you can see, the flows are heavily impacted by the dam. We no longer have a peak spring runoff flow in the Blue River, and then we have these prolonged low summer flows. And then in the fall, we have these really odd high flows, which is very unnatural for a Colorado mountain stream at this elevation. Yep.
Also flows below this mountain.
Yeah.
Not below.
Not below Dillon Dam. Yeah. For this portion of the project. Any other questions? Yep.
We just started seeing the CFS like 4,000. Also, there's a reduction of flows overall.
Yeah, so this is 2021, so that was a pretty, like, especially drought year. We are looking at 2021 and 2022 because that's when we're collecting other data for our project. But in wet years, it should be a higher magnitude as well. Any other questions, guys? Okay. So I guess before I move on, these shifts in the flow patterns, along with the other environmental conditions that I stated, that the green mountain acting as a nutrient and sediment sink, and then also changing the thermal regime of the river, are likely having a variety of effects on the food web and the ecosystem, which is the impetus or the reason why we wanted to study this system. And that leads me to our main objectives. So we have two main objectives for this portion of the project. The first is for evaluating benthic macroinvertebrate communities. And our second objective is looking at trophic dynamics of brown trout and mottled sculpin. And by addressing these objectives, we hope we can better understand how dams are really influencing this food web. So we're going to first start on objective 1, benthic macroinvertebrates. And this can be subdivided into two sub-objectives. The first being to evaluate temporal variation in benthic macroinvertebrate abundance and biomass. And the second is to evaluate temporal variation in their community structure. So to give you a little bit of background on this information and the terms that I'm going to be using in the next few slides, I'm going to first define benthic macroinvertebrates. If you guys haven't heard of these are just small aquatic organisms that live at the base of reservoirs, lakes, and streams. They're known as caddis flies, stoneflies, mayflies, and midges. And to look at benthic macroinvertebrate communities, we can use several different metrics. The first being abundance, which is just a count of the total number of individuals. And the second is biomass, which is the weight of these individuals. And biomass is a really important metric because it serves as a representative of how much energy content that an organism contains. So for instance, it's more beneficial for a trout to eat 2 large mayflies or stoneflies compared to 20 small midges. And so that's a good indicator of how much food availability there is in the stream. And then community structure is the number of species and the relative abundance or biomass. And this is important because it can indicate how the community is made up. And benthic, some of you may know, there are some sensitive benthic macroinvertebrate taxa. So if we see shifts in their community composition, that might tell us how the stream is doing. And then also, as I mentioned, benthic macroinvertebrates are a primary food source for fish. And so it's important to understand the relative abundance and biomass so we know how much food there is for the fish in the river. So moving on to the methods for this portion. For this objectives, we had on-site partners who are actually sampling the benthic macroinvertebrates. They used a server sampler, which if you guys have sampled stream invertebrates, you've probably seen these. But if not, it's what's shown in this photo right here. They're pretty much just nets that you put in the water and you pick up the debris and the rocks. And then all the invertebrates that are living in that area will be flow into the net, and then you can see what's in the stream. And so those samples are sent off to a consulting firm out of Oregon, where they identify all the prey or all the macroinvertebrates, and then they estimate their biomass. And they were taking samples of benthic macroinvertebrates during the similar sampling times as us and at the same sample sites. So we were able to compare macroinvertebrates that were in the river to what the fish were actually eating. So getting into our results from objective 1. This graph here is showing the abundance of benthic macroinvertebrates in spring, August, and October. As you can see, the relative number of invertebrates shifts quite a bit seasonally, where August it's really high, and then October we see a sudden drop off in the number of invertebrates. And then we can also see that the community structure based off of abundance changes seasonally. So in May, we have a majority of midge larvae and mayfly larvae. And then moving into October, we have mainly aquatic beetles that are making up the community. Any questions or comments on this slide? Yeah. Yeah, so that's what's, it's hard to say for certain what's causing it. And that's what's going to be part of our next portion of the project. But yeah, it could be the high flows. It could also just be the way that the life cycle of these macroinvertebrates. And so we haven't quite grappled with what's the cause behind it right now. What was that?
Size of the nets are really small.
Yeah, yeah. The colors and yeah are a little thrown off by this PowerPoint. Sorry, it's hard to read. All right, so this is now showing the benthic macroinvertebrates seasonally, but looking at biomass instead of abundance. So it's telling a slightly different picture. And as we can see here, May, we actually have the greatest biomass in the river. So the most energy for the fish. And then it slowly declines throughout the seasons, October still being the lowest amount of food availability in terms of quantity and quality. And then this also shows that the community composition is a bit different here as well, where in May we're dominated by caddisfly and mayflies, and then in August we're dominated by midge and mayflies. In October it's kind of a split between aquatic beetles, caddisflies, and stoneflies. So the key takeaways from objective 1 are that macroinvertebrate abundance and biomass decrease in October. So that's when there's the lowest amount of food availability. And then we also see that community structure varies temporally. And like I said, the caddisfly and the mayfly larvae dominated the spring community. And in summer, we saw a shift to midge and mayfly. In October, we saw aquatic beetles, caddis, and stoneflies. Yeah.
Could you compare your findings to what the eagle would have?
Yeah.
Relative?
Yeah, so that's what my next portion of the project is. I'm only a year into my project right now, so these results are very preliminary, but hopefully we can get a better understanding looking at the eagle. Yeah. Yeah, so I'm not sure what the exact mileage is. We're partnered with Blue Valley Ranch, which I don't know if you've heard of them, but they own a big portion of the river down there. And so there's sites that are spread out longitudinally along that gradient. Yeah, exactly, Jurassic Park. We're working above the big fish area, but. Awesome, any other questions and comments?
Do any evaluation of terrestrial or?
No, they do not do terrestrial. So that would be interesting to look at, but we're more so looking at how the dam's influencing the whole food web, the aquatic food web. But terrestrials definitely play an important role in the riparian and riverine food web system. And those definitely provide subsidies that are important for the trout.
When you're sampling the fish, though.
Yes, when we're sampling the fish, we'll, I'll get to that in the upcoming slides, but yeah, we do note if they're terrestrials in their stomachs or if it's all aquatic. Okay. So moving on to the second objective, trophic dynamics of trout and mottled sculpin. This can be broken down into 4 sub-objectives. So we evaluated temporal variation in stomach fullness of brown trout and sculpin. We also looked at their diet composition, their trophic niche breadth, and then the degree of trophic niche overlap between these 2 species. So again, a little bit of background info and key term definitions. Stomach fullness is the relative amount of food that is in the fish's stomach, and this is just an indicator of how much the fish is eating. Diet composition is the proportion of different food items in the fish's stomach, and so this gives us an idea of what they're consuming seasonally and if that changes. And then trophic niche breadth is the range of different food sources a fish is utilizing. And this gives us an idea of whether they have more specialized diets and they're only going after one prey item, or if they have generalized diets and they're just eating whatever's in the river. And then trophic niche overlap is the degree to which these two species share similar resources. And this is an indicator if they're potentially competing for resources. So moving on to the methods for this, I'm first going to start with the field work. So we sampled the lower Blue River in May, August, and October of 2021 and 2022. I'm only going to share results from 2021 because we're still analyzing 2022. But we electrofished, which have any of you guys electrofished before? That's okay, yeah, it's super fun. When the flows are low, it's fun. When the flows are high, it's not so fun. We had a few floaters in October. But we collect brown trout ranging in size from about 3 to 8 inches, and then mottled sculpin ranging in size from about 3 to 5 inches. And then with each fish, we measure them, so we get their length, and then we weigh them. And then we obtain stomach content samples by using gastric lavage, which is pretty much just pumping the fish's stomach and making them gag up whatever they've eaten that day, and then we collect those samples and bring them home with us. And these are just a few photos from the field. The top is when it's fun to sample in August, and then the second photo is in October when it's snowing and not so fun. And then we're sampling, we have our crew sampling fish on the side of the stream in the third photo.
Can you tell me why you selected brown and not brown and rainbow?
Yeah, so originally we were going to include rainbow, but there's so few in that reach that it just wasn't feasible. So our second part of the methods are back in the lab. So here we take this diet samples that we've collected and we open them up, and then we identify the prey that's in them to the lowest taxonomic level. It's a little challenging because they're usually pretty digested. So that means that we ID them to order or family if we're lucky. And then we measure their body length if they're intact or their head capsule width. And with those measurements, we're able to convert their length or head capsule width to dry mass estimates. So then we're able to utilize those dry mass estimates to figure out how much the fish is eating of the different prey sources. And here are just some photos of examples of items or diets that we've picked through and what's in their stomach samples. Can anyone identify? Yeah.
So if they're just
yeah, you may be able to look at DNA. That is a little out of our funding, I would say. For at least, especially for how important it would be. Like, I guess it depends on how kind of a resolution you want of what prey they're eating. But usually grouping by order is what's widely done in the literature, just because you want to know if they're eating mayfly, caddisfly, midges, or something else. So usually that's fine just to go to that level.
We'd also get a lot of pollution between the species in there.
Yeah, it would be pretty challenging. Anyone willing to take? Okay. This is actually a mayfly, a flathead mayfly, but it is a little challenging because it's pretty digested, so you can see where the issues come in. And then here is a caddis head. This is a Trichoptera hydrocyclidae head. So that's an example of when we just have a head in the diet and you're able to identify the organism based off of that. Yeah. This is a mayfly.
Yeah.
Yeah. Digested mayfly. Maybe decapitated.
Lower right is case carrots.
Yep.
Yeah.
And then on the left is a free living caddis, ahead of a free living caddis. Okay. So for the data analysis of this objective, first you're looking at stomach fullness, like I said. So for this, you're just evaluating first the proportion of empty diets to diets that had food in them. And then we are also looking at the relative weight of biomass in their stomachs compared to the weight of the fish. And so that just gives us an idea of how much the fish is eating in relation to other fish in the system. We also looked at diet composition. So like I said, that was just utilizing the dry mass estimates from the different prey items and then figuring out what trout are eating, what proportion of their diet is mayflies versus stoneflies, and so on. And then trophic niche breadth, we are using Levine standardized index. And so this is just to look at the number of different prey items they have in their diet. And then we also have trophic niche overlap, which is looking at how much the sculpin and the trout are utilizing these same resources. So getting into our results from our second objective. So here we have stomach fullness. Brown trout is on the left panel and sculpin are on the right panel. As you can see, throughout the seasons, the proportion of empty diets changes. So October, we have the greatest proportion of empty diets shown by that lighter block on the top for brown trout and for sculpin. And then in August, they have the least amount of empty diets within the fish that we sampled. And then this plot is just showing the relative stomach fullness. Like I was saying, it's the relation of dry mass in the fish's stomach compared to the fish's weight. And there's two things to take away here. First, mottled sculpin, which is shown in the green dotted line. They overall had more full stomachs compared to brown trout. And then we also see seasonal shifts in how full their diets are. In October, both species crash in how full their diets are. So here we're getting into the fun stuff. We're looking at the diet composition of brown trout and sculpin. So brown trout are on the top and sculpin are on the bottom. And we see that both of them are mainly eating caddisfly. And then we move into August and it looks a little bit different. The trout are mainly eating caddis and mayflies, and then the sculpin are mainly eating stonefly and mayfly, shown in those greenish yellow colors. And then finally, we have October, which is the most interesting. We see that fish are shifting from eating benthic macroinvertebrates to actually mainly consuming juvenile trout. So that is making up the majority of their diet. And these are small fish. We're sampling fish that are this big for brown trout, and sculpin get up to 130 millimeters. So it's pretty impressive that they're eating mainly juvenile trout for their diets. That does not include eggs. We didn't find any eggs in their diets, and that might be because they just digest so quickly, but we did not see any eggs.
In that section, when do the sculpins spawn?
So brown trout spawn in the fall, and rainbow trout spawn in the spring, and sculpin spawn in the fall. We didn't find any sculpin in the spring, sorry, to summer. Sculpin were not in the diets, so this is just trout that are in the diets.
You didn't find any sculpin in the brown trout?
No, but I will say like I said, we are sampling trout that were 80 millimeters to 200 millimeters. So I assume larger trout may be eating sculpin, but they're honestly really bony fish and don't have much meat on them. So brown trout fry are probably going to be more energy dense food compared to sculpin. Any other questions, comments? Okay. Yeah. Okay, so this third plot is showing trophic niche breadth of brown trout and sculpin, and larger values here. So this is the Levine standardized index. Larger values indicate a larger trophic niche breadth, which means that they have a more generalized diet and they're eating a variety of prey, whereas smaller values indicate that they have a more specialized diet and are just utilizing specific prey. And there's also two takeaways from this plot. The first being that mottled skullfinch and the green dashed are more selective eaters, so they're not eating a larger variety of prey compared to the brown trout. And then the second main takeaway is that there's seasonal variation in trophic niche breadth, and both species have the smallest breadth in October, which tracks with the resource availability. And then finally, we have Schiller's D, which is an indicator of trophic niche overlap. So here, higher values indicate greater overlap between the two species, and lower values indicate that these species are utilizing completely separate resources. And then that dotted line at 60 is what's considered ecologically significant for the amount of overlap they have. So you can see in May and August, they don't have overlap or significant overlap. And then in October, they are utilizing the same resources, which we saw were those brown or the trout fry. So the key takeaways from objective 2, first, we saw that stomach fullness was the lowest in October. And then we also saw that diet composition varied temporally from benthic macroinvertebrates in May and August to trout fry in fall. And then we saw the trophic niche area was lowest in October, meaning they had more selective diets in October. And trophic niche overlap was greatest in October, which means that they shared similar resources, those trout fry. Overall, these results suggest that trophic niche dynamics of brown trout and sculpin are very fluid, and they're able to adjust their feeding based off of what resources are available. Yep.
Any consideration given to
Yeah, for sure. So what we were doing is we are collecting fish on the margins of the river. And so their habitat overlaps quite a bit for the size range that we're looking at. Larger brown trout are going to be in the water column more in the middle of the run. But for the most part, these sizes share a very similar habitat. Yep. Okay, going on to our discussion and key takeaways from the whole research project. So we did see seasonal variation in benthic macroinvertebrate biomass and community structure, where we saw the lowest amount of benthic macroinvertebrates in October. The brown trout mottled sculpin trophic niches are dynamic and reflect those changes in resource availability that we saw. And considering the specialized niches in October mixed with, means they have selective diets, mixed with the proportion of diet overlap between these two species and the lowest amount of prey availability in October, this means that, or indicates that brown trout and sculpin are actually competing for resources. This is a photo of a rainbow trout. I apologize, I couldn't find a brown trout on the internet that was consuming that many trout fry, but I thought it exemplified our results pretty well. So our results, as someone asked earlier, these kind of bring up the point of how are dams actually influencing this community and this food web. Right now, we just have the preliminary results of what we found in the diets, but we don't really have a full understanding of how dams are impacting the whole ecosystem and influencing these food web dynamics. So for future direction, we're, like I said, going to compare the Blue River environmental conditions to the Eagle River and also the benthic macroinvertebrate communities. Specifically, we're looking at flow regimes between these two rivers, the thermal regime, nutrient availability, and the benthic macroinvertebrate communities. So hopefully that will give us a better understanding of how dams are impacting the system. And then we're also looking at additional factors that are related to trophic niche dynamics. So we're using stable isotope analysis, which is just a way to have more time integrated representation of diet composition. So that will give us a better understanding of how these species may be competing for resources, because we only had a snapshot of their diets from one day of sampling. And then we're also going to be looking at fish condition and how fish condition relates to trophic niche dynamics and resource availability. So with that, I would like to thank all of the help I've gotten on this project, both in the field and in the lab by many of the technicians that we've had supporting us, as well as the graduate students in my lab who have been very helpful. And then also would like to thank the funding support that we've received, which is a mix of Blue Valley Ranch, Colorado State University, and TU. And a special shout out to this chapter because without your guys' scholarships, me and many other students who have received your scholarships would be struggling a lot more in grad school because there's a lot of expenses that are not fun. So thank you everyone for your time. Oh, yes, and with that, I'll take questions. Yeah.
Your chapter 2, where you're going to be compared
sort of aims at this, but have there been any studies or is there any discussion between the biological community and the water management regulating dam rivers, moderating what they do so they're not letting such sizable flows affect the temperature, the macro invertebrates, the variations that you show. At the beginning, you showed a lot of negative effects of doing that.
Right, totally.
Are there studies or discussions with regulated rivers that are trying to moderate those flows and see that comparing it to what you're going to compare the Eagle and the Blue?
Yeah, for sure. So there's a lot of research that's been done on flows, environmental flows, and that's just trying to get back at that natural flow regime of a river. And that does help. Honestly, a lot of our rivers are super impaired by a multitude of factors, including the flow regime and the thermal regime, which is hard to fix when you have a reservoir, because even if you mix the top and bottom layer, you're still going to get pretty consistent temperatures and not get that natural variation in temperature that you should be seeing. And like we said, the sediment and the nutrients are also an issue being locked behind the dams. This research is part of a greater effort that Blue Valley Ranch is heading, and they're trying to improve the stream, and we're looking at, this is background information on how the dam has impacted the river. So there's talk moving forward about working with the dam and figuring out what some flows that are reasonable for the dam to release that aren't ecologically impairing, as well as potentially adding phosphorus to the river because it's a very nutrient depleted section of the river. And so there's, right now, like I said, we're in the preliminary stage of trying to figure out how much the dam has impacted the river, and hopefully that will inform management on what some beneficial things we can do moving forward to manage the system. Does that answer your question? Yep. Yeah.
somewhat related to that, this is a two-part question. Can you give any consideration to the opportunities and the portion of flows into the land?
Yeah. So,
Part two is the existence of publicly operated treatment works like wastewater plants along the Eagle specifically influential on the communities that maybe identify that watershed versus what you found was left.
yeah, so to get to your first question about looking at this Blue River, the upper and middle section of the Blue River, yes, I didn't include this in my talk, but that's part of chapter 2 is also looking at middle section conditions and the upper section conditions, especially the nutrients and the temperature and the flow, because that will for sure tell specifically like, oh, we have this amount of nutrients upstream of the dams. How much are the dams retaining those nutrients, or how much are they modifying the temperature? And I know TU and a few other collaborators are working on the Blue River. It's a big collaborative effort to understand how the upper and middle sections of the Blue River are being impacted. And so we're also kind of piggybacking on that, or trying to add information to their efforts and working with them to look at how all 3 sections are impacted. As far as the Eagle River being the benthic macroinvertebrate communities being impaired by sewage or wastewater, that definitely could be affecting the community for better or for worse. There are studies that that wastewater could actually be beneficial in alluviotrophic systems because it's inputting nutrients. And that also occurs in the middle section of the Blue River. I don't know, we haven't looked at the macroinvertebrate communities yet, so we don't really, I can't really speak on behalf of like how that's impacting their system. But yeah. Any other questions or comments? Yeah.
So you're concentrating on brown trout, now so two rainbows in the blue.
Yeah.
Are you doing any kind of evaluation to see if that higher number of rainbows that you see in the eagle results of all only browns?
Right. So we're actually not looking at fish when we're comparing the eagle and the blue. Unfortunately, time span of a master's project is very limited. So this is already a lot to take on for 2 years, unfortunately, but hopefully future students can take a look.
Just be doing that.
Yeah, and environmental conditions.
Okay.
Yeah.
And you don't want to do a PhD?
There's been talk. They're dangling the carrot. Yeah. All right. Well, thank you all for your time. I really appreciate it.
Thank you, Nitsa. That was great.
Yeah.
Microphone change here. Our next speakers, we have Natalie Flowers from Colorado Trout Unlimited. And we also have Kirk Benson, a teacher in a local school here that will be talking to you guys about trout in the classroom.
I'm gonna check my mic quick here. Here it comes.
There we go. So thank you guys so much for having me. My name is Natalie. I'm the Youth Education Coordinator for Colorado Trout Unlimited. I know lots of you, and I am so appreciative of the Cutthroat chapter, all you guys do for conservation, your support of the youth programs, your energy, your ideas, your volunteerism, all of that. Honestly, it's really humbling to have so many people that are so supportive of these programs and the energy that you guys give to these youth programs. So thank you, thank you, thank you. I can't say thank you enough. So today we're going to talk about trout in the classroom. This is just one of our many stream of engagement programs. So when we say stream of engagement, we think of a stream, right? So we have this beautiful little analogy that we really try to get youth in young and engaged at different levels, whether that's with River Watch, stream keepers, stream heralds, like you guys are going to do here soon. We have, fishing clinics. You guys do lots of youth programs as well, not necessarily totally in collaboration with the State Council, but Trout in the Classroom is just one of those. And our whole model is that it's a stream that connects these kids throughout their lifetime, hopefully into really an adult member and a lifetime member for TU. Next slide, please. So this is a cute little rainbow trout that's going to get released. And, oh, sorry, backwards, sorry, I guess I have to turn off the thing that automatically does, sorry. Okay. So Trout in the Classroom is a really special program because it connects students with their local watershed. we have a lot of different sites throughout Colorado. We actually have about 46 different sites. And this program, they get the eggs donated by Colorado Parks and Wildlife in the fall. And then they actually raise these eggs throughout the year in their classroom with their educators. And then they get to release them here in the spring. So I'm going to let Kirk kind of tell you a little bit about his site and what he's done with Trout classroom. This is his first year doing TIC.
Yeah, hey, my name is Kirk, Benson. I teach kindergarten through 6th grade STEAM. Although, Cindy, I might want to now identify as being a STREAM teacher because we're working really hard to build up our programming to get kids outside, engaged with the outdoors. I teach just down the road in Inglewood. We have about 220 students of all those ages, kindergarten through 6th, who have been engaging with our tank this year. It really basically started as a fish tank in a classroom. And we have it situated where every student in the school can walk by it every morning. And the research is pretty clear. Like seeing a fish every day does really good things for your brain and body. So baseline, that alone has been really profound for our school community. It's really rallied the adults in our school around a common purpose, and it's really been engaging for our kids. It started off with, like Natalie said, the eggs. My first graders and kindergartners drew pictures for the eggs to welcome them into the world, and they have. So adorable. But then the work just builds as the grades go on. It's been our like really big focus for 5th and 6th grade, but has really engaged the whole school.
Are the kids naming the fish?
Oddly enough, I think there's too many moving around that they can't quite pinpoint. But there's a few big ones in there that they have names for.
The names typically come out at release as well. Like a lot of times they're like, oh, I've got to name it before release this, like before release this fish. So you guys are really blessed because you have 10 sites in your chapter area with Trout in the classroom. So there's 46 sites across Colorado, and 10 of those are actually in the Cutthroat chapter area. So you actually have a second most number of Trout in the classroom sites. In fact, I'm just going to zoom in here if I can. No, not quite. I'm just not going to do it. I'm not going to mess it up. So really, you know where you're at. Like you can see, you're way up there, like number 49-ish. Like just imagine zooming in. There's going to be nice 10 sites there, and with Kirk and Cherrelyn being one of them. So it's really important that we have so much support, that you guys give so much support to this program, because these kids and educators, you know, it's hard to raise these finicky fish. You guys know it's hard to catch them, right? It's even harder, I feel like, to raise them. And, you know, we're dealing with tank maintenance issues and sometimes funding issues. And a lot of times the kids and educators, you know, don't necessarily come from a fishing background or even a background. Some of our educators aren't even really a science background. Some of them are art students or math students. And so the way that you guys can really help, I'll get here to just a little bit later on my slides, but you know, showing that support, whether programmatically or funding or in any imaginable way. If you guys have ideas on how you can support these 10 sites, please let me know. I'm here to kind of help guide the support and then direct, you know, you guys as volunteer leaders and really these knowledge experts on trout biology, on macroinvertebrates, and sometimes even tank maintenance and, you know, nutrients and nitrogen cycles. You guys know a lot of that too. So it really is helpful as well to have that support as well.
Those are the things we're really looking forward to. This is my first year, like Natalie said, leading that program. But Corey, I don't think he's here tonight, but just working with Corey, who's a member. At the beginning of the year, we had a snafu with a piece of equipment that couldn't be delivered on time. So he showed up right away in the morning. There were eggs sitting on ice for hours. He got equipment, he got it set up with my custodian. So just those little connections are fantastic, and it's cool for our kids to see what that can become as they grow older, as they sort of think about careers, as they think about, you know, life outside of school. We've we had one big event this year that was a STEAM Expo, and Natalie got to come. She brought a bucket full of macroinvertebrates, which was cool to see last presentation. To have our kids engage with that same kind of work and be able to study and look closely at what our fish will be when they get released in 6 days. But just building those connections, I know, are what make learning like more important for our kids, more exciting. So it's fun to see so many faces here and to build that up.
Yeah, totally. So one thing that I think is really special about this program is that, so it's a national program. So Trout Unlimited does this throughout the country. The council kind of takes its own spin on it because we have to work very closely with Colorado Parks and Wildlife and the regulations that we have for the state. These are actually owned by the state. They're owned by the citizens. They're owned by you guys and girls and people. And so these trout are eggs that are donated by Roaring Fork. Do you guys, Crystal River Hatchery, which is my hatchery's at. And so the hatchery donates these eggs, and then they get put back into waters that are publicly accessible for fishing. That is a requirement of this program, is that they'll actually go back out into publicly accessible waters. So hopefully they will raise, get bigger, eat lots of yummy macros, and then you guys can hopefully catch them. And but the other thing that I really love is that not only is it, really these wonderful partnerships with Colorado Parks and Wildlife and other partners, but we let the educators and even the chapters work together to really create their own curriculum and their own experience for their local community and their local watershed. I am overseeing kind of the youth throughout the state, the youth programs throughout the state. I am not specialized in your chapter area or in, Rocky Mountain Fly Pastors or anything specific. But when we have the partnership between a chapter and local TIC sites, then you can work together to build in that curriculum and build in what's really important for your local watershed, whether that's increasing awareness about, temperatures, or going and doing macroinvertebrate sampling to maybe understand why, maybe there's some here, or certain species here, but not here. And really bringing in the students to ignite that spark and that passion, not only the students, but also the educators, and then build upon the curriculum and programs. We do actually, it's exciting this year, we actually are going to be unfolding some curriculum for educators that maybe are newer to the program. They don't have to take it, but it's something that they can kind of fold in to what they're already doing if they're kind of scratching their heads, or if they're maybe their chapter isn't as strong in being able to support with ideas.
I can't say enough good things about the program. It's super engaging for me and my partners over here. I come home like showing her the camera with the live stream of the fish, and we have updates all the time. But just the learning for our kids, it's hands-on, it's engaging. I mean, they're working with living beings, and they got to see them as an egg and grow to a few inches long. So just that, again, baseline is like really special, but the science that we're able to pull in is really profound, honestly, for elementary school kids. They're testing the water daily. They're checking ammonia levels and the pH. My older kids are taking that data and they're putting it into spreadsheets, and they're calculating over time how these things change. They're getting ready to release them into the river, so they're making all the preparations. We just got our DNA test kits. We're gonna be sampling DNA from the water and then being able to compare that over time to what is still in the river. So the learning is exceptional, and my kids are just so excited about it. And again, every grade level, from cleaning the tank to just getting their hands in the water, to scooping out fish to weigh them. There's really fantastic connections. It's led to my district being really excited about me, but also about my kids too. I had a group of 4, 5, 6 graders who presented to our school board about the learning that they've been taking on. It's really awakened the community that, especially after COVID lockdowns, has been kind of insular. So is just super exciting. So thanks, and thank you guys.
So a couple of things here, I just want to highlight. These are actually all pictures from this year. So this is when we got our eggs. This is at Casey Elementary. So both Kirk and so Cherrelyn and Casey got funding from a donation that we got from the Taubman Foundation. And so we were able to fund both the site in Casey Elementary and then Cherrelyn. This fish was actually just released last week on Wednesday. It's in the South Platte now. These are the kids that released that little fish along with his brothers and sisters. And then this one was actually just from yesterday. They did a release up on, was it Niwot? I think what, where was it? Yeah. Yeah. Anyway, that was just from the other day. So I can't remember where I was yesterday, but yes. It was, I'm guessing it was the same brand. Yes. Yeah. Yeah.
When you say 10 sites, 10 schools?
That is 10 schools, yes. So when I say sites, I'm trying to be a little bit more inclusive because not all of our sites are schools. So, and we're actually growing, we grew exponentially last year, like double in size. I'm not sure if you guys are aware of that. I probably need to back up a little bit because I spoke to you guys last year a little bit about this, but just to catch up those that maybe didn't hear. So this is my, I've been with CTU for about a year and a couple months. So this is my second time really releasing the Trout in the Classroom. And around this time last year, we had 26 sites, so 26 different schools. And then when we started up in the fall, we had 55 tanks. Now, some sites had more than one tank, and then some sites now, their fish sadly died because they're hard to raise. So we have 46 sites that are actually releasing fish this year right now. So this slide is really what my ask is of you guys as a chapter, of you guys as supporting Trout in the Classroom. We really, I want to work with you. I want this to be a really good partnership. So I don't expect, you know, any or all of this, but I just wanted to highlight that this program couldn't be done without the chapter support, without the ideas, the volunteer time that I know many of you have put towards this program, the funding that you guys help support the youth programs with. And so moving forward, I really would like to strengthen, sorry, I feel like I'm losing my mind here. I would really like to strengthen, you know, any partnerships with all the chapters throughout the state to help grow this program. I already have probably another 15 sites coming in for this next 2023-2024 school year. And, you know, those sites are going to need programmatic support. They're going to need funding support. They're going to need support for if, you know, their aerator goes out and they're scratching their heads because they've got, you know, 28 kids just wandering around the classroom and they don't want their fish to die. You know, to have somebody be able to step in locally is really helpful. You know, I am one of 5 staff at CTU, so you know, sometimes I don't have the availability to go, you know, down to Littleton and help out at that tank. I also have John Davenport, which is my statewide TIC coordinator, and he's been super helpful in, you know, traveling around and trying to support that. But what we're finding is as this program is growing, which is a great thing, we're needing some extra hands-on support. And usually that's, you know, just coming in, checking with the teacher, making sure that they have the equipment that they need, making sure they have the programmatic support that they need. And then there are certain times of the year when it's, in my opinion, really, really fun to engage. So we usually are setting up the tank in August. And sometimes, especially our new schools, are going to need some help setting up that tank. They're kind of scratching their heads. Maybe they've never set up a big fish tank like this. They don't really know what a chiller's for. So we can kind of help work through that. In September and October, that is game on. That is when we are getting our eggs. We are super excited about it.
Each tank typically gets about 200 rainbow trout eggs in their tank. And so we have to deliver those eggs. You can imagine it's a pretty big day. We had, I'm trying to think, I know Ray and Corey, I want to say maybe a few others were able to help deliver eggs in the fall last year. And it's great because, you know, we get them directly from Coast River, and it's go time when they hit Denver, and they just kind of go in all directions. And then with that, it's, you know, tempering the eggs, making sure that they're the right temperature so we're not losing a lot of them, and then on-site support. November and March is a lot of growing time. It's growing for the fish, it's growing for the educators, it's growing for the students. It's a lot of learning time. This is a great time to engage with your sites and your students and educators, whether it's bringing out, you know, doing a macroinvertebrate sampling. We've had some chapters do fly tying with the students. We've had some go and talk about trout life cycle and biology. It's a lot of opportunities, and really the sky's the limit. I think it's just how creative you want to be and how engaged you guys want to be as a chapter. And then April and May is our busy time again. It is go time now. We are all gearing up. We've had 2 releases so far. Both of those pictures you can see before. And we have, you know, the rest of these, 44 schools that we'll be releasing here, mostly in April and May. We do have a few stragglers that we'll release later on in kind of June and July. But those are going to be more non-traditional schools, more like your community tanks or something that's going to be like at a library or something. And then really June and July is where, you know, we as a CTU and then a lot of chapters are fundraising and looking at the budgets and looking at how we can do it better next year, what we can show and support-wise, and then reassessing when and who is going to be coming back for next year. So last year, I was drinking from a fire hose for a lot of it, I'm not gonna lie. It was a great and fun year, but it was a big growth year for TIC, and we did a lot of changes. We actually had a huge change with Colorado Parks and Wildlife, and they were able to give us a testing exemption. So we know previously we had to test our fish for pathogens, and we had to do that with a lethal test. So we pretty much had to kill about 1/3 to 1/2 of the fish in the tank, which is really sad for students and educators, and then ship them off to Bozeman, Montana to the U.S. Fish and Wildlife Service and test those fish for pathogens. CPW and CTU put their heads together last year, and they came up with a fantastic plan where we now have a testing exemption, because it's very, very, very low risk that these fish are going to be having pathogens that they will carry into the wild. So with that, we get to release a lot more fish, and we don't have to euthanize any of them. And so, you know, really in June and July is where we did that work last year, where we did that legwork and trying to finalize our plan. And I anticipate, you know, kind of tweaking the program and making it more flexible for the educators, for the students, and the chapter support as well.
I'll just echo any support would be really appreciated, whether it's fundraising or coming over to teach kids how to tie flies or cast a fly rod. Being my first year, I'm dreaming already for what it could be for next year. So you're already brainstorming, you know, who can bring rods, who can bring the Velcro flies. So any of those connections would be really welcome.
It was like really cool today, so I come in like an hour and a half. There's like 7 teachers and a bunch of parents all standing around this person. Like to get like Tuesday and engaged like the whole community. So if you guys for anything that it's pretty awesome.
And I just wanted to say that I put it out there, and I think the educators are trying to take advantage of it as much as they can, that each student that participates in Trout in the Classroom, and one educator, so hopefully you're taking advantage of this, gets a free Trout Unlimited membership. So they are technically your members. Now they have to take advantage of that. They have to fill out their forms, right? And then I can submit it to national. But these are members. These are members of your chapter. And, you know, this is a great way for you to hopefully engage them and get, you know, potentially younger demographic, people with different diverse backgrounds, into understanding what you do as the Cutthroat chapter. And there's so many things, you know, I saw at the beginning, you know, about going to Lake Howe and, you know, your Earth Day, you know, thing. And there's so many opportunities. We as a nonprofit do amazing stuff. I am floored at the amazing stuff that TU, CTU, and all the chapters throughout the state do. What we don't do is brag about ourselves. So you guys need to brag about yourself, and we need to connect to these kids, these families, these educators with you more, so that way your membership can be boosted. You guys can start to build that partnership, that relationship with the next generation. And I love this picture. You may have seen it before. Sorry, hang on just 1 second, and I'll get you. Oh, sorry. Because I used it in another presentation because it's just so cute. This little kiddo drew this picture. Oh my goodness, just doesn't want to stay on it, does it? And it just talks about, you know, how they really start to see the connection between these trout and these little baby fry and what they're putting into the ecosystem. I'm sorry. Thank you. I apparently did not set it up right. It just keeps wanting to go to the next page. Any questions? Sorry. I saw a couple. Yes.
I'm a teacher and I'm looking to be a part of the program next year. Is there like a cutoff date and you have resources for like getting principal approval and funding and things like that?
So we don't have a cutoff date yet. I'm thinking it's going to be May though, so we definitely want to talk. We do have some opportunities potentially for funding. We're looking, we always are looking for, you know, chapter support a lot of times. And I think I just heard that you guys are actually giving a donation to the youth program. Is that right?
$2,000.
That's what I thought. Okay, I didn't want to like totally put it on it. Thank you so much. Thank you. That's definitely gonna help. And what I can do is we can give my card afterwards and we can talk for sure.
So Natalie, what does it cost to set up a tank in the school?
Thank you. Yes, good question. So the cost is about $1,500 to set up the basics of a tank. What a lot of schools are trying to do now is do what we call a STEM setup, and that's what we did for Kirk. So we have telemetry with that, and it helps monitor the tank. It graphs it out, makes amazing graphs. The kids can compare and contrast. You can speak to that a little bit here.
Yeah. We were out of town for Christmas vacation and got an email from the system that said ammonia levels, the free ammonia levels are super high. So it's a way for the adults to track the tank. But then when I'm back at school, I had the kids looking at the graphical data. It peaks every day at 10:05. Why in the world would that happen? Because you're feeding them. So it's been a really cool way for kids, for us to monitor it, but for kids to have an active role in that too, and then also be able to study that real world scientific data.
There's live cams, so you can just like log in and study where you are.
There is. It's pretty fun. We have some schools that actually put it like up on the website, like, and they have it like, so you can just go to the website and just look at the fish. It's got a 55-gallon tank. And so the STEM portion is an extra $600. So really we're looking at, you know, $2,100, $2,200. The ongoing maintenance though, so like the second year and the third year drastically drops. So that's really the basic setup and supplies. And so after that, it's about $300 to $500, depending on, you know, the needs. Sometimes, you know, a chiller, you know, breaks and you have, that's a hefty cost, right? So, you know, you have some of that in there, but typically after the first year, it's about anywhere from about, yeah, $300 to $500 to maintain, get your basic equipment and stuff in there. So you can, we actually have a discount, kind of with PetSmart, and we've got a whole, so it's on our website, which is actually great, because here is our website. So couple things, to back up, and then I'll circle back with purchasing items. I have a lot of volunteer opportunities, coming up for a lot of trout releases. In fact, we have one trout release on Monday coming up, so if anyone wants to join us. We also have a lot of other opportunities, especially one at Waterton Canyon on May 2nd. If you guys are maybe able to do that, we will be doing electroshock. Just saying, CPW is going to be out. There's some big fish in Waterton Canyon. It's a fun time. We need some help doing some stations. We have a casting station at that one. It's a big event with Arvada West High School. And then also Vista Peak is going to be there, another high school. And then Littleton High School is going to be there, although Littleton probably won't be participating in the stations themselves. But if anybody's able to help out, you can just go to our website and go to volunteer, and there's all these opportunities there to sign up. And then there's one link that will be all of our release events, and then you can just pick and choose which release event you want to sign up for. So any help with that is greatly appreciated. We need help, teaching casting sometimes. We need help at just honestly supporting the educators and kind of herding the cats. And also talking to the kids about CTU, about TU, about your chapter, about what you guys do for, that particular watershed. And anything that you guys know, especially local area knowledge, is so important to these kids and to the educators. It just makes the program and the release just all that much improved. Yeah, it's just great. Also on our website, make sure, oh no, I didn't put it on there because I wasn't thinking. I should have. I just updated our Trout in the Classroom page. So if you go to our website and go under, actually it's under, I believe, the conservation. Okay, so it's just on the CTU website, and then I believe it's under conservation, and then you can do youth programming, and then it's TIC, so it's a little clicks through the system, but there is a chapter resources page, and Kyle has also, our communications coordinator has also put in a leaders resources page, and it has a link to Trout in the Classroom as well for a chapter. For chapter volunteers. It's a specific page for you all, and it's resources that show you the cost and the equipment and where to buy that. It shows you a link to how to add in a new site or a new school that's interested in doing Trout in the Classroom. It has a program overview so you understand the ins and outs in that timeline that I had up here. A lot of great resources that I put out there for you to help you answer your questions. I also have cards up here, and I'm so happy to talk over the phone or over email and answer any questions. We usually do have a recommended purchase list that we go through, and that's mostly through Amazon and then PetSmart for convenience. And then we order our chillers directly from the supplier, and because we get a pretty good discount from that. But, if you guys have like an old tank or an old chiller, I know sometimes chapters have this in storage, let me know, and we can use those supplies and give those out to schools that are starting up that may not have the funding. And a chiller is about $600. So if you have a chiller, let me know, because that can save us some money, especially in starting up a new program.
Training for people that want to support the program, don't know what they're getting into, or if a chiller goes out in the middle of a period, what would they go do if they're called to help out?
Perfect, that's a great question. So I think that is where one way, or one thing that was lacking for sure last year when I was doing that fire hose, and then also that we're working towards setting up this year. We have a lot of really great resources on how to do a water change, what to troubleshoot with a filter, different things like that. I am also totally game for trying to build in a chapter training if that's needed, to help make sure that you guys have the resources to help support the tanks, especially if it's troubleshooting, or questions about the filter and the chiller, because the learning curve is steep. I'm not going to lie, it's tricky, and these fish are finicky. But it would be really great to have, a couple people that could jump in. You guys really already have them. You guys have some great volunteers that are there for your schools, but they're able to, come in and I'm willing to train more. I know John Davenport and I both want to strengthen that side of this program to make sure that, it's intimidating. I will admit, I had a fish tank and it was like a beta fish, right? So you don't have to have a chiller with beta fish. And so my training alone has just grown exponentially. And so I know that can be intimidating for some people. So I'm more than willing to talk with you, to have trainings, whether virtually or in person, to help, make that more of a better comfort level.
You might know this with Tank Creek, Colorado has a company that makes tanks called Cherrelyn Tank Company.
Oh. We need to talk.
I don't think I've ever seen a Lake Lehigh Day without the classroom.
We haven't done a Lake Lehigh Day for Trout in the Classroom. Lake Lehigh, you guys have an inn at Lake Lehigh, I'm aware of now. By setting up Screen Pearls 2.0, I was not aware of that before a few months ago. So Lake Lehigh, obviously you guys probably know more than I do even. It's owned by Denver Water, but it's ran through CCTU. And so a lot of times, I actually used to work for Denver Water in Waterton Canyon. So I was actually the person who managed Lake Lehigh back in the day. But I know it's a very busy, pond there. And so I've always not really put a lot of time and energy there because I always thought it was booked up. So we can definitely start talking about that, especially for expanding programming, like, taking kids out to fish or going releasing in Waterton Canyon and then maybe, fishing at Lake Lehigh or however you guys want to use that, since that's something that your chapter already has a connection with. Yes.
We saw muskrat.
Well, and it's a great resource because, they stock that usually so full that the kids can really actually catch fish. And it's a little hard sometimes when you're, a little youngin' and you just have been trying for a half an hour to fly fish and you're not getting any bites. So that's a great place to take it.
Squirming worms.
Right? Yes. Doing a fly fishing store support the program. I don't think so within your chapter area yet. So I'd be eager to talk with anybody. Right. Well, I know Anglers Cuddy down south in Colorado Springs area. They have a Trout in the Classroom tank there, and they help support the program. It's actually a community tank. So if we lose fish, which sometimes happens, then they will actually help resupply the local school or site that has lost fish. So we have talked with, definitely some of the, shops and things like that. I have, since I backed up a little bit in my priorities, and I'm not drinking, like I said, from a fire hose as much this year, I've been able to hopefully have a little more time to connect with different shops and different funding opportunities. If you guys have an opportunity that you are thinking of, I would love to have that conversation. It's a great, fantastic program, and sponsoring these tanks is a really easy way to not only show support for this program and really connect these kids with their watershed, but also to really get your name out there and connect yourself with it, whether it's a fly shop, whether it's a chapter, whether it's, just you working in the community and supporting maybe your local school. It's a fantastic, phenomenal program.
I used to be involved with Platis, and some of these started in the early 90s. We are now seeing people on boards of TV chapters that took these programs with these kids. So this is planting seeds. These are going to be the people that are taking over this chapter 15 years from now. So.
And I've also talked with National Trout Unlimited, and our TIC program. It's not the biggest. New York has the biggest. I think they have like over 1,000 or something in New York City. It's crazy. But we do have one of the most updated and really true like STEM stream programs, if you will, kind of like what Kirk was saying. We use that technology, that telemetry with it. We've had people, like that picture that would not stay up on the screen, do art with it, draw the fish, use mathematics and statistics to know guess how many eggs are going to actually survive and the survivability after you release them. It's just really a true, STEM, stream program, whatever you have I think that the fact that we've been able to really now grow our partnership with CPW, and now it seems like the chapters are really also, engaging and being, bringing their insight and their ideas. It's just, the sky's the limit. It's great. Another question? Well, again, thank you. Thank you for your financial donation. Thank you so much for your support, for your ideas. Please, if you do have time, some of them are on the weekends as well, some of the release events. So if you do have time, please check the website and let me know if you can help out. I do need probably at least another 5 volunteers, I think probably on May 2nd. And a few other volunteers throughout the release events, if possible. They're super fun.
All right, if you guys think you want to help in this area, we have a standard volunteer to help the chapter. Sign up and put tick on it. And I will take that information and pass it along to Natalie, so she can then reach out and tell you guys exactly where she needs that. Because I know going through the thing sometimes gets, I don't know where I'm at.
I can sign you up.
Yes.
You just let me know.
Okay, so again, back on the other table, volunteer, put tick on there, and we will get you a copy.
Okay, sorry, I had a few last little minute things, not this can go away if you want to. But I did want to let you know that you already have 4 girls signed up for Stream Girls. And that literally went up like last week. So that's for Stream Girls 1.0, and you have 2 of them returning for 2.0 so far. So I feel like it's going to be a really, really positive experience for the girls. They don't have to be a Girl Scout to be in Stream Girls, by the way. So it can be any girl. And we recommend Stream Girls 1.0 for, girls that are just kind of getting into understanding the stream, the river. Like Cindy said, we don't get to fish on Stream Girls 1.0 because we just run out of time. But Stream Girls 2.0, you do get to fish. And so if you, because you guys set it up in such a great way, where it's 1.0 on Saturday and 2.0 the following day on Sunday, it would be a really great opportunity for any young ladies. And then I did put some Trout Fest flyers. I have to do a Trout Fest plug because Trout Fest is coming up July 8th. So if it's not on your calendar, please put it on your calendar. Registration is free, or coming to the event is free. It's at Coors Field on a Saturday, and it's free if you register ahead of time. If you don't register ahead of time, you'll have to pay at the door. But it's a great, great event.
So Natalie, Kirk,